What I thought I would cover here is sort of a thumbnail about McKinstry, just to give a little context to the technology journey that I'll touch on. And then also, I'm really curious about all that the technology now is changing and enabling and how we design and deliver our work. And to be a specialty contractor, if you go out to 2 or 3 decades, you know, what is going to happen to our business? So I'll talk about that. So we started in 1960, and it was founded by Merrill McKinstry and George Allen. Mr. McKinstry passed away after a few years, so George Allen was the sole owner of the business. George was a professional engineer, and so out of the gate, we were a design builder. So our first year in business, we did almost $1 million design build job for an ice cream plant. And he was also interested in diversifying the business and also trying to take more responsibility inside of the mechanical space. So by 1995, we're a full-service design-build mechanical contractor, and we've also got architectural sheet metal and fire protection, and we had a separate temperature controls business outside of the company. And then we were riding the recession and bust to boom cycle in contracting, in new work certainly. And so the recession in the early 90s of the US caused us to kind of rethink our business model as we would sort of hire up and then hire down. And we were actually getting rid of our friends in the business, you know, in the bust times. So we started thinking about the existing building market and that there's a bigger market in existing buildings than there is in new construction. And so we started to develop a platform around this idea for the life of your building. And then it caused us to refocus our service business. And then out of that came facility management and issue management in buildings. I'll talk a little bit about that. And certainly renewing the asset of the building, and so the MEP infrastructure in particular through energy services work. And so that caused some new growth for us. We, in the upper left-hand corner there of the U.S., states of Washington and Oregon, that's where we sort of do everything that we do as a company. So we self-perform MEP there, plus energy services and facility management. As you move away from the Northwest, we're not a self-performing MEP contractor. But we do have a lot of offices that do energy services performance contracting. And for us, that's a professional offering, and then we use local subcontractors. The dots on there are data centers. So part of our journey in facility management was that the more technical the facility, the more value we could add. And so we gravitated toward life science buildings and also data centers. And so we became a 7x24 operator of data centers. And that, as you can imagine, with cloud and so on, has been a big growth part of our business. And so last year, we couldn't grow it as fast as the opportunity, so we joined with Brookfield GIS, and we moved 400 staff out into a separate company in the U.S. And so that they can actually grow that faster than we could grow it. What remains in McKinstry is we have about 850 office staff. We have about 1,000 people in the field. And revenues are a little north of 500 million US. So, so that is a little bit of a backdrop. Sort of back to this and this idea, as we, in the late 90s, were working for tech companies and starting to think about the speed of change, and they were asking us to provide more value at the end of the projects and help them transition into operation, and sort of the conversation just about the moving into an operational model. It wasn't so much about BIM and the model, it was how do we help our clients transition and help them operate. And so we actually, this knowledge response center idea for us is to manage issues in buildings, and we had a staff of 75 people in 2000, and we were spending millions of dollars in software to actually stand up a whole new business. And even in the the dreams that don't happen, we actually thought there was kind of an idea there that you could do an IPO. And then came .com 9/11, and we were behind the curve, so that didn't happen. But for us, the technology journey started with enterprise systems in the operate end of the spectrum. And so I'll touch on that a little bit. And then we wake up here, a couple of years ago, and we don't have the BIM-MEP pause, if I said that right, framework for a piece of what we do in the middle, but certainly in a design, build, operate continuum. So where are we going with data as a team inside of McKinstry? And are we actually sort of looking left and looking right, and that we're moving data for teams to use across our whole delivery? So, so we set about doing a roadmap. And so I'll start there. And this is really fundamental, and it's not maybe very interesting, but for us it was a good collaboration opportunity. And so, we just started with, what's the simplest steps that we go through to deliver a project. And then in our organization, a lot of things start on the whiteboard. And so we were saying, okay, well, what is it, in sales, scope, schedule, budget, or what is it in fabrication or supply chain or whatever? And if you could just have more of a linear description of data moving, what might it look like? And so several iterations, and so, I know this is not readable. And then we tried to, okay, we're getting too complicated, let's pull back and simplify a little bit. And here, we were just trying to go through the, sales phase, and my background is design. I'm not a technical person from an IT point of view, but there's this science of engineering, and then there's the model that results from that. And so I was trying to get our teams to separate calculations from actual model work in terms of thinking. And so we just, kept putting things up, and then we started saying, okay, well, I call it sort of a sandbox in sales as a design builder, where we typically don't have a model. We may not have much to be able to put a proposal together, but we still have to get a scope, schedule, budget, so we have targets to move through. And then at the end of the engineering modeling phase, before we're headed to fabrication, we need to recheck scope, schedule, budget, and we want that connected, obviously, to the model in some way. And so this was a wish list. At the same time, we were sort of pointing out where, what are our software tools at the bottom, and then that circle that says Spectra, what have we built ourselves that might sit in the middle? And so we're a strong believer in a base of design. If you write down what you're going to promise to the customer and to yourself, then you have a good chance of delivering on it. And so our base of design kept getting more and more thought, but it's actually bits and bytes and data. And so we said, well, we want to connect that because a lot of those inputs go straight into our HVAC cooling load software. So let's just, how do we get that data straight in? And then how do we get dimensional information from the model? So we'll take a Revit model and we'll actually lay out all the zones and name them, and so it can look to the base of design. If I'm a conference room, it knows it, and it'll pull it into our load calc. And then we'll run the load calc, and then it'll run back up and actually look at selection software, chilled beams or whatever, and then it'll drop the chilled beam in the model, and so that we've got this nice tight loop. And it's real easy to edit from after that. So we've been thinking about, sort of the silo of engineering, but then are we actually moving data downstream to the next team and so on? So anyway, that was our purpose here. This is maybe a little out of date now. I think our future is having factories, so I just took liberty and I said we're going to call ourselves a factory, although we're not. And then there's not very much here at the end because on moving into operation, because we have a whole separate team thinking about, we're doing all this operational work. How do we get that connected back to a model? And then certainly in new construction, how do you take objects in the beginning and enable the data to move forward into operations? So anyway, that's just a topic that's been alive in our organization to see if we couldn't expand our conversation a little bit. So we have this idea, and it came from working with a technology client, that in buildings, when things go wrong, here at this facility, if there's garbage in the parking lot or a tear in the carpet or a lights out or hot cold call, most of those have a business rule. When this happens, here's the vendors, it's in-house staff, it's out-of-house staff, it's a 1-hour call, it's a 3-day call, it's a whatever. And so the idea was just if somebody can have the catcher's mitt for issues in a building and then put the business rules with that, and then a team can actually work that through to resolution and keep all of the stakeholders involved, tenants and owner and property manager and so on, and then work with the delivery staff, whether it's outside vendors or whether it's in-house staff, or try to not dispatch anybody. Certainly connectivity with buildings and go in and analyze systems. So this call center team, they can kick an idea over into in-house, either an energy engineer or a service tech, and actually try to remotely fix an item. But the whole opportunity is that, for the life of a building or for the life of a system or a piece of equipment, there are day-to-day issues that if you had all that life cycle of data about the operational components, or operations in the building tied to the component, then when something is starting to look out of sync, too much service, it's time to replace it, or there's some chronic issue going on. And then you can learn from aggregating data across many businesses and many buildings. So, and we rebuilt this here again over the last 18 months. So now it's we're in the cloud and backed up, and we've got all kinds of fun procedures, and it's a mobile device, and we can put QR tags on equipment, and so the tech can go up and just hit the QR tag and have all the service history, point of use, and so on. So this is an offering that also was built out of dispatching agnostically. So it was built not thinking about dispatching ourselves. This was to go across the US and dispatch any vendor anywhere. So we've got about 350 million square feet, so 35 million square meters or something, of properties across the United States that report through this system, 7 by 24 to track. So that was one piece of operations for us that we heavily invested in technology. In 2000, when we started doing energy services performance contracting, it took us to projects like this, and these are always on a guaranteed payback basis. So this is a US football stadium. In the lower right and upper left is we replaced the lighting on the roof, and they, it looks like it's all for cool color and so on, and they're always changing the colors, but it was really to save energy against the old lighting system. And then in the lower right, that's a solar PV array on that large exhibition hall roof. The lower left is just taking an old courthouse on a steam system, steam heating system, and getting it on a new boiler plant that we built offsite and then delivered in one weekend on the roof. And then those are charging stations. But behind every project for us is the scenario building of look at everything, audit everything for energy and water. There's all kinds of individual discrete measures that we could perform. What's the constellation of that? And then how do you communicate that with a client and with the team? And so one of the tools that we have been experimenting with is the size of the bubble here is just the size of the dollars involved on an item. And then the color is the best payback in dark green to the least payback in dark blue. And so with this client, here's all the things we looked at, and now it's time to build scenarios against their financial performance model. They're always complicated, but simply we pulled back into, okay, a 15-year model or 10-year payback model or whatever. And so here, what we have done is, since 2010, that's just showing, you can click on that bubble and go straight into the database. But the idea is that we can go through and then select, and so this is going to zoom back, and so that's 30,000 different total cost of estimate in there against each asset change. And then if we want to go in and just look at, hey, we've got a new facility or portfolio, show me all the chilled water studies and estimates and drawings that we've done in the past, and so that's chilled water. Or you could go, hey, what about all of the thermal storage? So we have all these categorized, and they're discrete individual items, and we've got all this data now from all the studies. And the last little part of this video is, well, just show me all the completed and contracted ones, and then maybe from there I want to launch. I only want to look at completed work because that has final drawings and final maintenance estimates and operational estimates and energy estimates and so on. So each one of those records has a rich amount of data behind it, and so getting to all of that information was tough. And so we built this in 2010 as a big database. That's about $1 billion of delivered work in the last 7 years. So when we do these energy projects and they have a guarantee, then we want to be tethered to the building and get real-time data. And again, a lot of this conversation is, we built these enterprise tools before there was a model, and not that there wasn't a model, but the idea that we wanted to connect to the model. So one of our big challenges now is none of this data was architected, or the systems weren't architected in a way to connect to a model. And so that's a big conundrum we're working through right now, is how do we actually do that? This is just a map in the upper left, and these are all the buildings in this portfolio that we're monitoring real time, and we have an aggregate energy guarantee, and so month by month we're showing here that in total we're okay on our guarantee. And then we have demand charges in our utilities, and so peak electric use in the month gets tracked, and then our team is analyzing that across this portfolio, and they're trying to figure out which are the buildings we can go out and do demand work in and actually lower that peak charge. We try to not leave anything to chance, so we put up dashboards for building occupants. We call that Power Ed. And we get the occupants involved and see what's going on with energy and water, and the chance for them to make those little tiny adjustments that can save 10% of the resource use in a building. And then systems that are out of calibration are a real problem when you're trying to remotely monitor and then remotely act. Because if you can't trust what the screen says, you got a problem, but you can't believe the data, then you're in real trouble. So they wrote some analytics, and they're sniffing here a VAV system and looking at each VAV terminal. And the color there, that certainly when it gets to red, there's a high likelihood that it's out of calibration. And so then we'll go out and actually inspect and verify and get it calibrated. And these are all Tableau reports, and they stay connected. So if you clicked on any one of those, it would take you back into where the data comes from, and you can analyze from there. So visualization has become a big part of how do we deal with data. This is a heat map of fan speed on the systems in a building. This is a high-rise that we worked on a couple of years ago with an energy retrofit. And the whole point was, we're going overboard with alarms. As an energy contractor, we want to know when things are starting to be out of sync with how the building should operate. And so in pulling back a little bit and try to smartly alarm, but also smartly visualize and find the pattern that you need to act on, maybe when it wasn't an alarm. So here you're seeing fans running on a Sunday about 4 weeks ago, and 3 weeks ago they got it down less, and I'm hoping that if we went in a couple of weeks ago it would have been off. And so this is just to try to find a different way to monitor these systems. So maybe one of the highest value propositions that we've stumbled into over the years is we're really good at going in and looking at discrete parts of buildings. We know how to help manage or to advise as a consultant role. And then as a mechanical, electrical contractor over the years, we would get called in. Somebody's going to buy a building and help us. We want an assessment of the MEP systems, that kind of thing. Well, then with the energy business, we were looking at many more systems in buildings than just MEP. And so then it's like, well, you're taking care of all the harder systems. Would you get a complete assessment done, even if you have to bring in other team members? Fine. So this is a portfolio of schools, and the color of the bubble is its general condition on a color scale, and then each of the items, those little rectangles, are a discrete system or component. It might be glazing or roofing or finishes or whatever, and so we're pretty good at grabbing all this data, but how actionable is it for a customer? And so this, I don't know if you can read it, but it says it's $297 million of deferred maintenance in this portfolio. And here I just clicked, okay, well, let's get them to do all the MEP systems. We can't really do that, but if you sorted this down to MEP, it goes down to $190 million. If you say, okay, what about equipment that's got 5 years or less of life left? That would take all the potential work down to $50 million. And then our best funding comes from classroom-related issues, so all the highest impact on classroom would take it down to $28 million. And what about the best performance? Let's get rid of and only look at high energy use buildings, and that takes it down to 20 million. And maybe there's a high school that's got a budget, so you take that out, and I'm down to a little over 15 million. And then you could go line item by line item on each system in there and say, oh, you know, that building, we've got a controls retrofit already budgeted, let's take that out. And so I'm under 15 million here. The point is that the clients now with the web portal can actually go in and build scenarios on the fly, where this used to take us months, where, you know, they'd say, what about this scenario? And we'd come back and run the numbers because we had it all, but then you had to compile it and give it to them, and then that, you know, instantly, well, that just makes them think of a new scenario. Well, what about this? When you have to go back and do it. So anyway, so we're having some fun both with the visualization and then also the idea of working closer with clients and actually helping them with faster decision making. So, so again, those are all things that were not connected to the model. I mean, you can imagine our energy business goes out and finds old buildings. You know, it's hard to actually even find old original design drawings in a lot of these buildings. So anyway, we're living in this two types of world, highly modeled and then unmodeled. So I'm really curious about where we're maybe headed in the future. You know, this model has unlocked this idea that we can build faster and you know, move the data and maybe operate a little more like manufacturers and so on. But as a business, you know, what is R&D and how fast is it going to move into mainstream? And so we enjoy participating in all kinds of things that are going on in the industry, and we're playing with a few ourselves. But I have sort of the guts to know about how do you make business decisions with all these things that are going on. And so I'm always interested to look to where the manufacturing sector and those consumer products industries have come from, and certainly where they're going. And you know, there's this idea of a new industrial revolution out there, and some are calling it the second, and some are calling it the fourth. But certainly with all these new technologies that have moved from R&D, and it's not that they're not evolving quickly, but you know, those are now starting to truly impact and help lower the cost of manufacturing. And then here we are as a construction industry, and you know, it's often talked about when are we going to have our first, you know, revolution. And so, but the good news is we're all here and we're talking about it. And the one thing that is quite different that we can be proud of is safety. I mean, you know, I think we have a truly transformed market today in this couple hundred years relative to safety. But from the other ways that we build, maybe not. So, so today, it seems like, you know, all those other technologies that used to be out there are now in our space. And we're playing with those and starting to make use of them. And then everything about the past in manufacturing, we have been trying to move into our industry and still are. So we have actually more going on in our industry than in the manufacturing industry in terms of change at the moment. And so this, to me, you know, feels like we are now past a tipping point, and we can say, hey, man, we're actually in a transformation. But this, to me, is overwhelming at a business level. And the one great thing that you have going here is all your businesses have aligned to actually go together on a big spend in terms of standardization. And you know, we don't have that going on in the U.S. So, so what does disruption look like as an MEP contractor? This is the Broad company in China, and I think many of us have seen the videos where they can put up a high-rise in 20 days, or you know, a two-story building in 24 hours around the clock or whatever. But it's just interesting how they set about to actually design differently to enable a way to manufacture the components so that the building goes together in a new and different way, and it's all built for speed of final assembly. And I've toured a few different kind of manufacturing operations and talked to a couple of CEOs, one who was retiring and said, I missed it. You know, we've been working on lean and trying not to say lean, but we have improvement teams and we're doing all kinds of things for 30 years. And if I had just told them focus on speed of final assembly, I could have faster gotten to the same message, because when you focus on final assembly, it organizes everything up front, and so certainly you would organize to be safer, you would organize your supply chain, and so on. So speed of final assembly in the field seems to me to be where we are all going with how we are aligning data and how we build. So I'm sort of curious if you had a couple $100 million war chest and you had the best of the best from Google and Tesla and Tektronix and Flextronics and so on from the industry, and also went and got the best of the best in terms of construction talent and said, hey, we've got some customers that think we're onto a great idea, and they're going to give us all their business, and so out of the gate, we get to start with $500 to $1 billion a year in revenue. So we've got projects, and we've got the best staff, and we've got a lot of money. How would we design and build buildings? And our idea is that we can do this in half the time and half the cost. And so there is an example of a company like that, and I'm sure there are many. I just happen to know about this one because they have some operations in the northwest of the United States. And so they've entered the 3-story and less apartment building market. They've got, $500 million in backlog, and they're going to do about $1 billion, I think, in a year or so of actual delivered projects. And they've raised $225 million, and they've got 550 employees, and and they are a technology company, and that's what they tell you on their website. We happen to design and build buildings, but we're a technology company. And so their modeling focus is my words. It's about objects and rules of the objects, and then configuration in the model. And so, my understanding of their model is they happen to own architecture firms and have in-house structure, architecture now, mechanical, and so on. But their idea is that we know how we want to configure, and so they can give a different design team in any market the platform, and if you design on our platform, out the end, we get a design for manufacturable product, and so then we can deliver in kit form the entire building to your certainly custom site and local code, and then in a certain respect, your custom dimensions. And then notice that in there is MEP in the walls. So the MEP contractor, and so we're working with this company on a couple of projects in the Seattle area, and we're helping in this hybrid design right now where they haven't built all the platform yet, and they still have to get these projects done and so on. But in studying those, what's left for the MEP contractor after somebody else buys all of the product and then puts it all in off-site and then sends it to the job, the lowly mechanical contractor to do the plumbing is a final assembly connector, and there's maybe 5% of what was the revenue left, and you've got all the liability of all the final connections and leaks, right? So okay, well, this is apartments and low rise and whatever, but on their website, they already have a whole other product that they're going to put in place, and it's heavy timber construction. And so they're working on cross-laminated timber systems, floors, columns, and so on. And they're building plants in the Northwest to deliver these, and they're going into the mid-rise and high-rise. I think now maybe the idea is you can get up to 20 stories or something in heavy timber construction. And it's commercial application. And they're using the same business model. And also on their website, and they're a prime contractor. They will take MEP inside of that contract, and they'll do the work off-site. And one other interesting component, when you read between the lines on their site, I think they think that when they're a several billion-dollar a year supplier of built product, they're working direct with factories on all of the commodities, and so they'll start a whole other business and be a supply chain to contractors like us, just because they can buy as well or better than anybody, and they'll skip the local distribution. So they want to disrupt our local distribution network of commodities, I think. And so that is also a potential disruption in there. So I think about this in a couple of business models. Across our MEP business and complex jobs to not complex, and new construction to tenant improvement and whatever. I just use the aggregate that we're sort of a 20% off-site labor business today, put 70% of it in the field and 10% for modeling and detailing and so on. And then what is their model? And their, that generic there. We worked with another startup, a real fun company out of Seattle called Sustainable Living Innovations. And their idea for the market was to do steel and concrete apartments starting in the 5- and 6-story size in an urban setting. And could they get to be the same price as wood construction with smart design, smart supply chain, and really, where does the savings come from? Speed of construction. So the idea was to take a 5-story building that was modeled, that this one architect had just worked on, and that builder on that job was a 14-month delivery of this apartment. And this architect, who was the CEO of the startup, he said, I think we can do this in 5 months. And so let's go to work on it. So he put a team together, and we joined the team as a designer, builder, MEP. And so the very first meetings were, okay, well, how are we going to deliver this job in 5 months? Well, gosh, then we want MEP in the walls, certainly, and we're going to bring the walls in. And this is steel and concrete, so we're going to have a deck above us, and we're bringing in walls below that deck. And wow, we can't have plumbing going out the top and the bottom, so we have to reorient the whole system to move horizontally through the walls and then get to end vertical walls that can come in 2- or 3-story lifts. And so the idea was, when you design for speed, it took us, the engineer, into a total different space, and how you configure so that you can get all the work off-site. And then we ended up building a mock-up of a 2-bedroom, or a 2-bedroom unit and a studio unit in a warehouse. And so we built all these things off-site, us with the general contracting team, and then we assembled on-site. And this is about the labor stack that we ended up with. So there's a 25% labor savings, more in modeling. But this key that we were just 20% of our labor was the final assembly on-site. So here recently I was just playing with, well, what if you took the generic stack of the top, which is project cost, and so I've got subcontractors and pre-construction and materials and equipment and installation and so on, and just some real generic starting points of how much of project cost is in that item. And below is everything that's above, but it's only the labor component. So below it really is pre-construction, which was design and fabrication drawings and so on, plus some project management. And then the big stack below, is the gray, is on-site labor, and then you have off-site labor. And so today, it's just so normal that fabrication happens in mechanical rooms, and it's also so normal in our market with our competition that multi-trade racks, where you align systems and get all the horizontal racks out. So that's what I was calling the baseline here. And then getting toward getting all the vertical racks aligned in design, what can you go vertically with in a building, getting that aligned in design so that you can then rack things vertically is not yet done all of the time. There's some early work in our market on that. But I was saying, okay, well, that's the next way to get more labor off-site. And then after that, how do you get the distribution that's happening horizontally? So if you've got it racked vertically, horizontally, and from the mechanical room, that next frontier is the horizontal work off of those systems in the building. And how do you get that to be more kitted and more modularized? And if you could then you're certainly moving more work off-site. And then, okay, well, now let's get the MEP in the walls. And so total cost, and again, this is all just ROM information, but then certainly total cost can come down, and really it's happening from total labor cost shrinking. But here, all of a sudden, oh, you're going to build the walls off-site where our labor was increasing. Well, now what if that goes to more of a wall contractor, and what if there's a new product out there? So do we start to lose our off-site labor even though the labor was sent off-site? And then, okay, well, now we're in the walls, and so our digital supply chain works. So to enable just-in-time delivery of all these components, and it's going together fast in the field, and we got all this from modeling, and it's a manufacturable model, and we're getting all of the right components out in kit form to the right player off-site. Well, if you had 2 or 3 weeks in planning, maybe it would take a month. In the Northwest, we could have our work made by you. I mean, you know, so this whole idea that are our shops tooled up and are we competitive enough to hold on to this business, or as the bigger shops grow and are more mechanized, you know, is it just natural that we start to move our supply chain as an industry just to the biggest and best fabricators, and so we start to lose our own labor when you start to engage the supply chain. And then at the end, once you've got all this data working, then if you go back and say, okay, we're really trying to build these things fast. So who are the factories that are going to show up? You know, the trains, the carriers, whatever, that say, gosh, you know, we're in the system business, and if you go out 20 years, is the idea that, you know, with objects and modeling and artificial intelligence and so on, is the idea that you can give a configurator to an architect, engineer, anybody, and the system will find its way and get designed and optimized in the cloud. And so factories are going to want to supply the systems turnkey, and that's what I'm curious about. And so all that's left is a little bit of on-site labor for the business. And so in a revenue model, what happened to our business in this if we're not building an off-site business while the work on-site is evolving over the next 20, 30 years? So anyway, this is one of my big curiosities. So in these evolving systems where we're all prefabbing and now we're all thinking about kitting and doing kitting, and we're going to get to these modularized systems, and then will we get to these turnkey systems? You know, I'm no futurist, I don't know. But certainly we're working on cost, and on the bottom, we do know that the same work done off-site, given average conditions, is safer, faster, often at a cheaper price, and it gets our general contractor and owner of the building faster. So there's this gravity working on the bottom here of everything we're doing is to try to get work off-site. And to enable that, you know, we're sort of entering the phase of trying to get manufacturing engineers into our business. We don't have our first one yet, but that's in our conversation, to join our design team. We do have software engineers now in our business, so our ratio is, we're at about 1 per 20. So for every detailers, we've got 50 to 60 detailers in our business doing fabrication drawings. So we have 3 software developers working with them. In engineering and our new construction and heavy improvement, we've got about 60 designers. And so we have 3 software developers. And so, you know, in 5 years, will that be not 1 to 20, but 1 to 10, and in another 5 years, will that be, you know, 1 to 5? And I think as an industry, we're going to end up 1 to 1, you know, 1 subject matter expert to 1 software developer. And that's the future of how you actually do work. And then, you know, our trade partners, I think, have a big challenge. You know, we have these systems that are installed by electricians and plumbers and pipe fitters on an HVAC system, and we're all working on the same system as sheet metal workers, but that's not what our clients want. Our clients just want an HVAC system. And so as we move work off-site, and so, you know, the work at my station, you know, in a factory, you know, I'm working on a refrigeration part of it, and you know, in 3 months, I could learn all I need to do to be just excellent at this. Not a whole system. I don't even know how the system works. So, but this 5-year apprenticeship program our teams go through as trades, and then they know anything and everything, but they won't be able to compete on a wage basis with a factory setting where people are getting paid just to do the work in front of them. And so I think this level of skilled labor to turn out these systems, in aggregate, all the skills are needed, but not actually to deliver the system. So anyway, I think there's a big change coming for our trade partners. That's a challenge. Okay, so, you know, computational design, artificial intelligence, Moore's Law, whatever. So I found this here recently, and it's just showing, you know, the transistor count, and with Moore's Law, you know, things doubling every 12 to 18 months in computing, and also the cost maybe going in half. And the prediction every 5 years that Moore's Law is going to break, and that those predictions are out there again, that maybe this is not sustainable exactly the way it's been in the past. But if you look at, you know, the recent 10 years and the transistor count, and then Moore's Law in the same article takes you to extrapolating from, that was at this point, but here's today. And just in, this is 2021, my count, that's less than 5 years. Just this idea that the computational power, and with this idea of learning computers and this whole industry that's emerging around artificial intelligence and trying to find its way through automating things, and we are going to get automated. And then we add that with robotics. And so there's at the local university, there's a construction management class, and they always end each quarter with what is going on with technology and construction. And so I spend a lot of time on YouTube looking for different robotic video clips. And I was just amazed at what's out there going on. This one in the lower right-hand corner, the moderator is talking to these two robots, asking questions, and then the robot has to think, but then it is answering back, so there's a translation going on, and so it's clunky to watch. And then he steps out, and then the two robots have a debate. So we're just at this very early stage, but maybe there's this glimpse. That didn't work out very well. But the idea, so Kevin Kelly, he's fun to read all of his information. And this future of AI and robotics, and that maybe over time, everything that we do today is at risk to being lost to robots with artificial intelligence. So I think this study, the 47% of potential for jobs to be lost to technology, I don't remember if that was US or global, certainly developed countries was the topic. And then I've heard this number that in our industry, in designing and building buildings, it could be as high as 88%. I can't find the source for that, but I've heard it twice, and it's on the internet, it must be true. So, but we're in an industry that if then can be replicated. If this object is in this building and you write the rules and you know how to configure it, I mean, there's a lot that can happen in the artificial design of buildings, and then certainly if robotics comes along as promised, that we can be certainly kind of outsourced as humans. And there's another conversation about when do AI and robotics surpass all human capability? And so a technology conference in San Francisco I went to a few months ago, one of the speakers there said that 2045 is the current idea that when AI and robotics are combined to surpass anything that I as a human can do, cognitive or otherwise. I mean, dexterity and thinking and all, So, I got in this business in 1978 as a rookie engineering intern drafter, but it was to be an engineer and design HVAC and plumbing and fire sprinkler systems. And today our design team, the fundamentals are the same. We're doing modeling, and we've got real sophisticated software, and we produce more product certainly than I could do in 1980 as a rookie engineer. But I'm starting to have these conversations with engineering interns and our new hires out of college, which is in a soft way, you went to school to do this and you're here to do that. We as an industry are gone in less than 30 years in the way we think about how we work today. And what is that life cycle for somebody who's 22 years old, and when they're 52, the change that is in front of us, to me, seems to be just staggering. So back to, in a business context, this idea of going through iterations that are enabled through technology, and thinking that these might be sort of 5-year cycles. It used to be, I used to tell people our business cycle was 10 years, and it was because of materials science and products and building buildings. And then we ended up on, InfoCenter and these issue management platforms, and that business cycle was 6 months with software, so it's kind of a weird world to live in. But it seems like now we're starting to have to deal with the business cycle of change with software, and I have no idea what these items are that are in R&D today. So where I say phase 2, computational design, visualization, IoT, sensors, and analytics, whatever that set is, that becomes normal in 5 years or so, and then there will be a new set of R&D, and many of these things are being worked on, but when do they actually make it in and get to be standard use in our industry? I don't know. But this seems to be where it's all going. 80% of our labor, MEP, on-site, then only 60, then only 40, and then 20, and eventually is it just 5? And how do we start to change our business model to adopt to this kind of speed of change? And I'm sort of curious about, do we already know in some respects how buildings can be built faster and cheaper, certainly safer? And are we slogging it out in a path ahead? And we've talked about in our business, do we need to get a few people out of our business and start a technology company that sits alongside of our business to give it the freedom to change the way the industry can change and not be held back by our business, which has a lot of momentum and change is hard and big in aggregate ways. And so are we actually going to keep up, or is it the startups who decide to design and build buildings substantially different, and they're just going to come in and take our business because there's a whole different industry to be invented? So I found this quote maybe 15 or 20 years ago, and for me it used to be that if we were in a peer group and gosh, we'd go visit 7 or 10 other contractors, and every time and they were happy to give us that little tidbit. And when we aggregated all of that, if one MEP company could just take all the great ideas from good friends in the industry, and you're not competing, and it's like how you're doing this CAD standard, that if we could just take the ideas that are in play and bring all that back and do that, we would be great and maybe better than our competitors. But now when you add technology and what's going on and outside of construction or being experimented in this industry, it just seems to me that we actually know a lot about our future, and the question is how fast that we're going to go after it. So that's it. Thank you.